All right, this question here is a little bit tricky, but, well, that's putting it mildly, actually. All we have is the heights of these. Now, I was thinking about this question. What if I took something and I stretched this way over here? And maybe I could do that and then just use the backwards key. So let's say I do that here. Let's say I stretch this way over here. And look at that. It doesn't seem to change the height. I think that's true. I'm just going to push the back key so I get back to where I was. But let's do that again. All right. So if I pull this out, I'm not changing the height. It's staying at 12, right, and 9. But look at that height of x. It doesn't seem to change, does it? So I think it doesn't really matter what the length of that triangle is there. Okay. So I guess I can just go ahead and let's just label those. So I'm just going to label this one here. And I don't want to call it x because we've already used that up. So maybe I'll call this one y. Okay. And then so I've got this little one in here. I could call that z. And this one here, if the whole thing is y, it would be the difference of the two, y and z. So this would be y minus z, right? And I can see two big triangles there. So let's start with this first one here, which let's go ahead. This triangle here, the first one, okay. So we've got that triangle there, and then I've got the other one here, okay. This one here. I wish I could kind of highlight vertically, but it doesn't want to let me do that. Okay, you get the idea though. Alright, so there's our two major triangles that we're dealing with. And so then if we look at x here, well, look at these angles. These are right angles, which means that these are all parallel, right? All those are parallel lines because they stem from right angles. So I'm going to have some similar triangles here, okay? So let's just focus on the green one to start with. So that's triangle ABE. So triangle ABE is similar to triangle CFE. Right? You see those two triangles? Take a look at them. They're similar, right? And then let's look at the pink one. So we've got triangle, I guess, CEB or DEB. So triangle DEB, that's that big one. Yeah. Is similar to triangle CFB. Triangle CFB. Let's just double check that. DEB and CFB. Okay, so that's true. Okay. Now, what are some things that are true about similar triangles? Well, the corresponding parts are proportional, right? So this big side of this triangle, y, over this side, smaller side, 9, the legs, I guess, the long leg over the short leg. So y over 9, okay, that's equal to y minus z over x. That's equal to y minus z over x, correct? Yeah. Let's double check that. And then similarly, we could look at similar situation with the pink the pink triangle here. Okay. So y over 12 for that one. So that big leg over the small leg, y over 12 is equal to right? So y over 12 is equal to z over x. So z over x. Z over x. Okay. What else do we know? I don't see anything there. I'm going to try to see if I can... I have 3 variables, so if I could somehow isolate a variable, that would be helpful. Okay, so let's try another thing here. Also, we can look at, like, going back to this first triangle, 9 over x, so that big bottom over this small bottom, or let's go with the small, x over 9. So x over 9, I always like to keep my denominators as the numerical values. 9x over 9, okay. That will be equal to y minus z, right? So that's this part here, over y, right? The small one here over the big one. Okay, similarly, we can look at the other triangle there. So let's go x over 12 again. X over 12, so the small legs, x over 12, is equal to, let me see, z over y. Z over y. Okay. All right. So, is there anything I can simplify here? Oh, look at this here. Look at this here. So I'm just gonna let me get a highlighter here. This right here, I could try to break this fraction into pieces. Okay, so I'm gonna rewrite that. Let me change colors actually. So I'm gonna rewrite this to x over 9 equals, this is y over y is 1 minus z over y. Minus z over y. Okay, does that help us? Well, we still have 3 variables. It doesn't seem to be that helpful. But this z over y, I saw that before right here. Right, look at this. So we've got z over y here, and we've got z over y here, right? So I could substitute x over 12. What happens if I do that? Well, then I've got that same variable there. So I'm going to end up getting a situation where I just have one variable. That's going to be super easy. We're all downhill from here, right? So x over 9 is equal to 1 minus, and I'm going to substitute that value there. Okay? This is x over 12. This is the critical part here, right? So we substituted that. In here, right here, okay? So now the easy part, right? So I'm just going to add x over 12 to both sides. So I'll have x over 9 plus x over 12 is equal to 1. Okay, if I get common denominators here, or I multiply everything, let's see, clear those denominators out. So let's say I multiply everything by, let's get green here or something. Let's multiply everything by, what would do it? 36, right? So times everything by 36. That's going to be, right, 4x. And that is going to be 3x equals 36. So 7x equals 36. So x equals 36 over 7. So 36 over 6 is 6, so it's a little bit less than, so 5 point something, and that does seem pretty reasonable. Yeah, that seems pretty reasonable. I actually thought about, what like averages here, but these are not really to, you know, I wonder if there's probably another way to do this, but this is the way that I went with it. All right, that's it. That was a doozy.